Hey everyone, my name is Colin Kirby and I'll be presenting my research project on real-time stock market insights using big data. This project really is just going to explore how large-scale financial and social media data can be analyzed to further improve market predictions. All right, if you are familiar with the stock market, it's pretty easy to understand how it generates massive amounts of data, considering things like stock prices, volumes, trends, and traders rely on this information. But in more recent years, social media has become a more important factor in influencing market movement. Like platforms like Twitter and Reddit capture public sentiment, which can significantly impact stock prices. The challenge here for us is that while stock data is more structured and organized, social media data is very unstructured, noisy, and difficult to process. The problem I'm facing approaching this is how to effectively integrate and process both types of data into real time for better market analysis. So getting into the motivation, why does this matter to me? In any sort of high frequency trading, decisions need to be made quickly. But as of right now, with traditional batch processing methods, they introduce unnecessary delays, which further limit traders' abilities to act on current market shifts. And also, social media is a really early indicator of potential stock market trends, which makes it really valuable as a resource, but it's really underutilized in current models. So my goal is really just to build a scalable pipeline that can process this financial and social media data in real time, which will help with improving the market prediction accuracy. Okay, so before diving into our current approach at a solution, let's examine some of the challenges that exist in stock market predictions today. A lot of the studies that I researched showed that a lot of the current models rely on batch processing, which again is just too slow for real-time trading, and for more active traders, it just really doesn't apply. Furthermore, some of the past approaches with sentiment analysis with social media struggle with things like sarcasm, bots, and misinformation, making accuracy a big deal and a big challenge within this approach. And additionally, a lot of machine learning models that are used for market predictions require large-scale computing power, and the more traditional and simple, less computation heavy models also fail to adapt to most sudden price shifts, which is a big issue. So from these limitations, there's a strong need for a real-time system that can do both and processing both financial and social media data while maintaining high accuracy and scalability. All right, so building on those previous challenges from the research, our project focuses more on four key issues. First, we're going to start with the real-time processing bottlenecks. A lot of the models rely on delayed batch processing, which is too slow. We can't use that. It won't be applicable to our goal. Second, data noise and manipulation, fake news, spam, and bots are going to heavily influence sentiment analysis. So we need to figure out how can we can avoid that. Third, computational constraints, again, handling massive and financial and social data streams, is going to require significant resources of which I don't know my single PC could handle in my old GPU. And then lastly, latency and scalability. Most of the systems right now struggle to update insights in real time. There's so many things going on in the world. Being able to react to those is very important, and it makes it very ineffective for high frequency trading if it doesn't respond. So to address these challenges we found in our research, I'm going to provide the solution of a real-time big data pipeline. I'm going to break down our solution by each of the challenges that we saw in the research, like starting with how we want to avoid batch processing. Our system specifically is going to process the stock market data and social media sentiment using Apache Spark streaming. This ensures continuous data updates because it's more real time, and again, avoiding batch processing is very important to us. And then for our sentiment analysis, we're going to be using NLP models, which are natural language processing models, with something like Hugging Face, which is a company that provides these type of models. And this will help extract more meaningful insights from social media platforms, like Twitter or Reddit. And then getting into our financial data, they're going to be gathered through APIs like Yahoo Finance or AlphaVantage. I'm still debating on which one I want to use. There's different aspects that are both beneficial, but we'll see down the road. But these both just do allow for real-time price tracking. And then getting in with our machine learning models, a lot of the past research use things like random forests and LSTM, which is long short-term memory networks. And these will just help correlate the stock movements with social media sentiment, combining what we're analyzing through the previous approaches. And then hopefully by integrating these technologies, our framework will enhance accurate decision making for traders. And from the research, we saw a lot of improvements, through their approaches. But again, there was a lot of issues which we were trying to correct. But from those past research studies, we can anticipate several key improvements with our system. First of all, faster decision making, the most important thing. Our real-time approach eliminates the batch processing delays, and it takes a more, again, real-time approach to just solving this issue. And then second, getting into the improved marketing predictions. A lot of the AI-driven analytics can help detect some of the trends that we're trying to study earlier based on the sentiment shifts in social media. And then third, with the NLP models, we want to improve that sentiment analysis accuracy. Our NLP models will help filter the noise and extract more reliable insights. That's the goal of these. And then finally, getting into the scalability, we want a more scalable and efficient processing. And Apache Spark is going to help us do this by allowing us to handle more large-scale market data seamlessly, making the system a bit more adaptable for high-frequency trading. So to properly explain our improvements that were mentioned in the previous slide, we will need to do so through a proper evaluation. For this model, we're going to be doing it across three specific areas. We're going to do speed, accuracy, and scalability. Speed will be measured through latency. We know with processing the financial and sentiment data, with Apache Spark streaming and with the NLP models and how fast the data is coming through. Accuracy will be determined by comparing our model's prediction with the actual stock movements. So, like if we predict the stock to go up and it goes up, that's great. If not, then we lost money or whatever. But then with our machine learning performance, we'll probably just use an 80-20 train test split. We just want to make sure it can generalize to the data well with the 20% testing split, and then 80% for overall, making sure the model is trained well. And then again, for improving the robustness of the model, we're going to be using benchmark testing, which allows us to stress test our system under higher data loads. So to summarize this overall presentation, the proposal, real-time stock analysis is very essential from my point of view for high-frequency trading. I think it's very important in the whole world of finance, but I think it's very underrepresented, especially with social media and how they interact. And I feel like a lot of the current models don't really explain that well. So our proposed solution, is bridging this gap of integrating financial and social media data using real-time streaming, the natural language processing models and machine learning techniques. And then I think some of the future works that we might implement, I don't know if I specifically will, but they can involve more testing the system on larger data sets. Again, a big limit for this testing in the future is probably going to be the access to technology I have. I'm running it on an older GPU, and being able to process all this data at once might be difficult. But again, I haven't completely began that yet, so getting into it is going to be a learning curve. But this research is really just going to lay groundwork for overall improving real-time market analysis and providing traders with more actionable insights through a unique approach.